This is geometry. Today's date is Thursday, April 16th, 2020. Today's date, or yeah, that's today's date. Today's lesson is 7-5, points inside, outside, and on a circle. So our objective today is to use the distance formula yet again. Now we are determining where a point is relative to a circle. Is it inside, outside, or on the circle, just like the multiple choice down here. Let's do example 1. I should point out also that they typically don't give you a graph. They'll never give you a graph. I'm just doing this so that you can understand what's visually happening instead of just me explaining it in words. So we have a circle that's centered at p is equal to negative 2.5 or negative 2 comma 5. So negative 2 comma 5 is right there. And how big is the circle? Is it that big? Is it that big? It says the radius is the square root of 31, which is hard to visualize, but it's a little bit between, the square root of 25 is 5, and the square root of 36 is 6, and it's kind of halfway in between there, so it's around 5.5. So this is just to approximate. Again, you don't have to graph this. So 5.5, if I go 5.5 to the right, so 1, 2, 3, 4, 5.5, so it's this point right here. Let me go ahead and undo those dots and then make a point right about there. Oh yeah. Make a point right about there, and then go down the same amount. Let's go ahead and skip to the, what does the circle look like? It looks like this. So this is the circle that's talking about in the problem, so now we can visualize it. Okay, so we're talking about point A, which is different from point P. It has a different letter, and it has the coordinates 1, 0. 1, 0, and we can, I don't know why that's doing that. 1, 0, which is if our picture is accurate, it's outside the circle. So the answer is outside the circle. But how are we going to know that? Like, what if it was our circle was slightly too small, and maybe it's on the circle? How do we prove this mathematically, or especially without any graph? How can you do it purely with algebra? That's what I'm going through right now. So what we're going to do is we're going to find the distance between point P and point A. If this distance between P and A is bigger than the square root of 31, then it's outside. If that distance is smaller than the square root of 31, it's inside. And if it's equal to the square root of 31, it's on the circle. So it's just distance formula between our two letters A and P. Again, let me remind you, our distance formula has two representations. The easy one is your change in x squared plus your change in y squared. I should have parentheses around the y, and that whole thing square rooted. And a little bit more, the more textbooky formula is x1, or I guess they do x2 first. It doesn't really matter. One way or the other works. So x2 minus x1, that quantity squared, plus y2 minus y1 quantity squared, and then the square root of that entire, maybe I should draw my square root symbol not through the other formula. So either of those formulas are going to be perfect today. I'm going to be using the first one because it's a little bit easier. So what is the change in x between -2 and 1? And that's mathematically represented by what's 1 minus -2, and that's 3. Let me write out my work so you're not just seeing it, or you're not just hearing it. So what is 1 minus -2? I guess I technically am using the second formula. That's my change in x, and I'm going to square that. And what's the change in y? So it's 0 minus 5. Well, the change in distance there is 5. We're going to square this negative, so it's going to be positive regardless of what's happening. And then I'm going to take the square root of that entire quantity. So again, because I have a double negative inside here, 1 minus -2, it's really 1 plus 2. So 3 squared is 9, plus -5 squared is 25. And again, I'm taking the square root of that entire quantity. 25 plus 9 is 34. And we now know the distance between P and A. And let's see, do I have a line tool here? So this distance right here, that's not a line. Click on I have to click on it. Maybe? No, that's the line width. That's the line tool. Silly me. So this length right here is the square root of 34. And the actual radius over here, so let's draw the radius. This radius of the actual circle, they told us in the problem, is, let's scroll up to it, square root of 31. Square root of 31. So pictorially it makes sense. This distance between P and A is bigger than the radius, and it also makes sense algebraically. It's a bigger number, so it is outside the circle. We can confirm it is C. So now I want to try an example where I don't have a picture, where I don't automatically know the answer right away. So I just chose a random letter Z and chose some random numbers, and I'm going to say it has a radius of 4. Oh, so it's not a square root this time. It's a little bit different, and you might see something like this on Khan. And then I have another point, and I want to figure out if it's inside, outside, or on the circle. And it's kind of hard to tell, even by guessing. Even guessing is hard. So let's go ahead and do the formula. What is the distance between Z and Q? Okay, well, the change in X is 6 minus 3. I'm going to square that quantity. And then the change in Y, I went from -4, then I'm going to subtract the -7. Those are the Y coordinates, -4 and -7. And then I'm going to square that quantity and take the square root of that entire quantity. Okay, so I have 3 squared, which is 9, plus, okay, so I have to be careful over here. I have double negative, so it's really plus. -4 plus 7 is 3, and then 3 squared is also 9. Okay, so it's really the square root of 9 plus 9, or the square root of 18. All right, well, we have to compare that to 4. 4 is the radius, and this is the length between Z and Q. Is 18 bigger or smaller than 4? Obviously, it's not equal to 4 because it's square root of 18, and that's not a perfect square. Well, I can write 4 as the square root of 16. That makes it a little bit easier. Okay, now it's pretty clear. Square root of 18 is bigger than the square root of 16. If it's bigger, it's again outside the circle. And if it's, yeah, if this length between Z and Q is bigger, it's outside. If it's equal to that number, it's on the circle. And if it's smaller than the number, it's inside the circle. I realize that I gave the same kind of example twice, but I think you guys can probably figure out between those letters once you do the math. Cool, and that's all I have for you guys today. That concludes Notes 7-5.